For number 1, they're asking us how many packs of pencils and erasers the teacher would have to buy so that he would have enough for one of each for each of the 36 students with no leftovers. Well, if he has 36 students and the pencils come in packs of 12, you need to see how many packs of 12 you would need to buy to get 36. Since 12 times 3 is 36, he would need 3 packs of pencils to get 36. And since the erasers come in packs of 9, you have to say since 9 times 4 is 36, you would need 4 packs of pencils. 4 packs of erasers, since they come in packs of 9. So let me see, this part would be your answer. For number 2, to find the least common multiple, it's quicker to start with the highest number. You're going to list its multiples until you find something the other number can go into. In the case of number 2, we'll go through our 5's times tables until we find something 3 can go into. 3 cannot go into 5. 5 times 2 is 10. 3 cannot go into 10. 5 times 3 is 15. 3 can go into 15, so 15 is the least common multiple. We'll do the same thing on number 7. We'll start with the higher number 16, and we're simply starting with the higher number because it's faster. 6 cannot go into 16. 16 times 2 is 32. 6 cannot go into 32. 16 times 3 is 48. 6 can go into 48, so 48 is the least common multiple. On a problem like number 7, you probably don't know your 16's facts off the top of your head, so you're very much welcome and encouraged to use scratch paper to get those answers. For number 8, we have 3 numbers we need to find the least common multiple of, but we're going to start with the highest one still. 4 can go into 8, but 6 cannot. 8 times 2 is 16. 4 can go into 16, but 6 cannot. 8 times 3 is 24. 4 can go into 24, 6 can go into 24. So 24 would be the least common multiple. We will use least common multiples to help us do least common denominators. In lesson 6, we're estimating fraction sums and differences. So it means in order to estimate, we're going to have to round. To round a fraction, you have to determine whether the fraction is closer to 0, 1/2, or 1. For a fraction to be close to 1, the numerator and denominator are very close together because that means you have almost the whole thing. If a fraction is closer to 0, that would mean you wouldn't have many of the pieces out of the whole. It would be closer to having none. If a fraction is closer to 1/2, you can tell that because the numerator is about half of what the denominator is. If you look at number 1, 8/9. 8 is only 1 away from 9. That means you're only missing 1 piece out of 9, so that's close to a whole. 1/6 means you have 1 out of 6 pieces, so you don't have very much, so that's closer to 0. 1 plus 0 is 1. For number 12, 11/12. 11 is just 1 away from 12, so that's close to a whole. 4 is about half of 9, so 4/9 would be closer to a half. 1 minus a half would be 1/2. Numbers 5 and 6, we're using the table and answering some questions. In number 1, they want to know number 5, they want to know how far did he run during weeks 1 and 2. Week 1 was 8 3/4 miles. 3/4 is only 1 apart. It's close to having the whole thing. So 3/4 would round to 1 whole, plus the 8, the whole number 8 that was already there would give us 9. 1/5 is close to nothing because it's only 1 out of 5, plus the 7 wholes that were already there would give us 7. 9 plus 7 would give us 16 miles. For number 6, they wanted to know how much farther did he go in week 2 than in week 3, so that's a subtraction problem. 7 1/5, we just now rounded that to 7. 5 5/6 has a fraction of 5/6, which is just 1 piece out of 6 that's missing. You have 5 out of 6, which is closer to a whole, plus the 5 wholes that were already there would give us 6. 7 minus 6 would be 1 mile. So it was about 1 mile greater on week 2 than 3. Now we're going to get into finding exact answers when we add and subtract unlike fractions. First thing we need to do is find common denominators and make them into like fractions. We'll start with the higher denominator, just like we did with least common multiples. Start with the higher number because it's faster. 2 can go into 10, so 10 is our least common denominator. Here the denominator stays the same, so the numerator stays the same. In 1/2, 2 times 5 gives us 10, so we have to multiply 1 times 5 to give us 5. And then we add 3/10 plus 5/10 is 8/10. Then we always have to make sure our answer is in simplest form. So we ask, is the fraction improper? No, it's not. Can it be reduced? Yes, because 2 can go into both 8 and 10, so the fraction would reduce to 4/5. For number 17, we need to find common denominators and write like fractions first. Start with the higher denominator, 5. 3 can't go into 5, so we have to keep listing our multiples of 5 until we find something 3 can go into. 5 times 2 is 10, but 3 can't go into 10 either. 5 times 3 is 15. 3 can go into 15, so 15 is our least common denominator. 5 times 3 gives us 15, so 4 times 3 gives us 12. 3 times 5 is 15. 1 times 5 is 5. Now we're ready to subtract. 12 fifteenths minus 5 fifteenths would give us 7 fifteenths. And when we ask to see if it's in simplest form, 7 fifteenths is not improper and it cannot be reduced. Number 15, once again have to find common denominators for 8 and 2. Start with 8, 2 can go into 8, so 8 is our least common denominator. The denominator stayed an 8, so the numerator is going to stay 5. 5/8 equals 5/8. For 1/2, 2 times 4 gives us 8. 1 times 4 gives us 4. So 1/2 equals 4/8, and we can add that. 5/8 plus 4/8 gives us 9/8. 9/8 is an improper fraction, so we need to divide 8 into 9. You can do that division in your head, or you can do it on scratch paper. 8 goes into 9 one time. We have a remainder of 1, which we put over the divisor to get our mixed number of 1 1/8. 1 1/8 cannot be reduced, so that's our final answer.